Hello everyone, in this tutorial video, in the previous video we had calculated what is the equation of the actual velocity of water beneath the surface of the earth, and that was given by Darcy's equation. Now we are going to see the other equation which were developed before Darcy, and these equations are known as empirical formulas, which is known for determination of the groundwater velocity. All these two equations were given by these two scientists, Schleicher and Hazen. These were given before Darcy. So they also calculated an equation, they derived an equation which gives the actual velocity of the water below the surface of the earth. So the equation which was given by Schleicher is this equation, and that given by the Hazen is this equation. So if we know these unknown quantity, let's say k dash I d square 10 over mu. So if we know these unknown quantities, then we can definitely calculate the actual velocity of the water, where k dash is a constant, I is the hydraulic gradient, d10 is the size of the particle, and mu is the viscosity of the water. Similarly, that equation is also given by the Hazen's, where k dash and k double dash values are respectively 4000 and 10,000. So let us understand this by one numerical. Let's suppose that the viscosity, effective size, and hydraulic gradients are given, and now we have to determine the actual velocity using both Schleicher and Hazen equation. So how we can determine both of these value? Let's say its equation is known, the unknown quantities are given. Let's say k dash value is given, I we know, d 10 is being known, mu is known. So just simply put the value, then you can calculate the actual velocity of the water. Similarly, we can also calculate by the help of Hazen. So these two equations were developed before Darcy, and they also help in determining the actual velocity of water. Now next, come to the next topic. In the previous slide we had seen what is transmissibility and coefficient of permeability. So there is a relationship between both of these, and that has been established as T equals to kd, where k is the full depth. Now next topic is the drainage of water. So what is basically the drainage of water? There are water that is being stored in the saturation formation below the surface of the earth, that are the aquifers and various other formation. So if we extract the water from all these formation, saturation formation, by either, let's say, by construction of the wells, by the help of springs, or by infiltration gallery, or by construction of the well. So if by all such means, if we try to extract the water from the aquifer, such type of formation, then that is known as drainage of water. Drainage means to just take out water from the below of the surface of the earth by either of these ways, by constructing wells, tube wells, infiltration gallery, whatever could be the medium. So that process is known as drainage of groundwater. Next terminology is the groundwater yield, specific retention field capacity, peculiar water yield. So what are these basic things? So let us just understand this by one. As we know that below the surface of the earth, as we know that a three-phase diagram of a soil in which there is volume of void. Similarly, when the rainwater, when the precipitation goes below the surface of the earth, this water is being filled in the volume of the void. So in the drainage of groundwater, we try to extract these water from all these volume of the void, and we extract these, and finally we get them in the wells or in the tube wells. So that process of extracting the water is known as yield. Okay, so whatever the water that we could possibly extract from all such type of the saturation formation, okay, that is only the available water. But there are certain other water also which is known as peculiar water, which can't be extracted from such type of the formation. It's only because of the molecular force of attraction, because such type of water cannot be easily extracted from the molecular level of the soil. So these are the peculiar water which can't be extracted. But apart from that, whatever the water that we extract is known as the yield of the water. So if we try to determine what is the specific yield, then that is the volume of water that we have actually obtained by this gravity drainage to the total volume. So that is known as specific yield. If we multiply it by 100, then we will get in percentage. Next thing, that what is the specific retention. So whatever the peculiar water which could not be extracted from the surface of the earth, from below the surface of the earth, that water which have been held under the action of gravity to the total volume, that will give us the specific retention or field capacity. Multiply it by 100, you will get the in terms of percentage. So if we just add both of these, specific yield and specific retention, then you are going to get the porosity. Okay, so that is for today's lecture, and we will carry out the next topic in the next lecture. Thank you for listening.